Good morning, folks. This is video tutorial number 14, which belongs to the playlist dealing with motion design in 3D experience kinematics. Motion design is an application in 3D experience which is basically the revised version or the enhanced, modified version of the 3D trying to remember the name, mechanical system design and the mechanical system experience, which deals with dynamic and kinematic simulation of rigid bodies. Now they have enhanced it, so they have enhanced it and modified it so that it's more user friendly, and it's called motion design application. Now, this particular tutorial 14 is essentially continuation of tutorial 13, where I do exactly the problem that you see down here, except that all the engineering connections are created in the assembly design, and then once you go to the motion design, they're automatically converted into joints. In this tutorial number 14, I don't create any engineering connections in assembly design, but I create all the joints manually in the motion design application. Okay. Uh, so uh, and these manual creation of the joints are actually done with markers. And markers, if you're familiar with CATIA V5, the DMU kinematics, there were these things called joints with access systems. Essentially, it's that, but they don't call it with that name. They call it markers. Generally speaking, when you make an assembly and you go to in motion design, markers are automatically created at the origin of the part, okay? But these are not useful necessarily to create joints. So you have to create your joints, your markers manually so that they can be put together and they become a joint in the motion design. uh, that's the part that I'm going to be making. This is the assembly that I'm going to be making. It's called robotic arm. It's the, as I said, I've done all the parts, manually created all the parts in tutorial 13. So I'm not going to bother doing that again. The first 5-10 minutes of the tutorial 13 is actually making these parts, but instead I will start from that point on without any engineering connections. I also want to remind you that there's a playlist that I have for mechanical systems experience and mechanical system design, both kinematic and dynamic problems, and that's here. So this problem is actually solved there too, and also in my playlist for CATIA V5 mechanism, DMU kinematics. So it's right there. Keep in mind that these are not the only, this is not the best way, the only way, obviously, and the most efficient way of solving a problem. I have the help description from creating markers, and I'll put these things on the screen because I'll talk about it as I go along. This figure specifically goes with a prismatic joint. This one goes with revolute joint, and this one goes with point curve joint. And these are the joints that I need to do the problem. So let me go back to my assembly, and I'm going to move these things apart. At the end of the day, this base is going to be stationary, but let me move these things apart. Have to be an assembly design, and I'm going to use my manipulate. So let me translate stuff. I'm going to translate this. No, I'm going to translate this thing. Hang in there. I'm going to translate it in the direction Y. Which one is Y? This one is Y. There, and there, and there. And what I have done is this piece is also as a separate part. It's called path, but I'll just leave that thing the way it is right now. Okay, I've separated these so that we can see it better. Now, let me move on to my motion design. As soon as you go to motion design, it says that I'm going to create a mechanism for you, uh, which is this name. You can change the name if you want, and I say okay. And obviously, when you look at it, there are no joints here because I haven't done anything. I haven't created any joint. And these are all the markers that you see. For example, if you look at this, the marker for that part, let's see for a second. Uh, let's see now. This is if you look at the bodies, each one of them has a marker. This is the marker for the link 1, and link 1 is that orange one. And this is the marker for link 2, that's the green one. And link 3 is the vertical member. And the path is also there, which happens to be right there. And of course, the base is the marker for the base is over here, right there. Good. So why don't the first thing I'm going to do is to create a joint for this base. The joint for the base is just a fixed joint. So we go and create a joint right there. See that? Right? Joint, fix, and select the base. So the base is now fixed. And if you look at the joint, this is the one. Now, because this path is assumed to be stationary in space, I can create a rigid joint between the path and the space. So let's go and do another one. Joint. Let's do rigid. Rigid. And it's between uh, uh, the markers. I'm going to be using the markers for the base and the path. The path is over here. So what it did, it created a rigid joint between uh, the, the path and the base. And what happened in reality is that, remember these coordinate systems over here? It coincided them together. Okay, there were two coordinate systems here, markers here, one for the base, one for the path. As soon as I said rigid, it take the path and moved its marker to that base location. Good. All right. Now I want to take this fellow, I want to take this hole and put it on that shaft. So that's a revolute joint. But what I'm going to do is the markers that I have here are not useful. I have to create markers manually. So how do I mean by that? You may have to change this thing if it doesn't work. Here is the marker and select the body. Let's actually select the base first. See that? It says select the body to add the marker. And I'm going to do it by selecting geometry. I don't want to type in things to get your marker. I'm going to do it by geometry. I select there by geometry, and I'm very careful. Look at what happened. I'm going to go and select this, for example, circle, and it did create a marker right there, right there, at the center of that circle. Now, uh, the Z direction, if you this figure becomes extremely important. This becomes extremely important. So Z is the direction of the axis of rotation, and in this case it's down. So the other marker, when I create it, I can make this thing down. If I don't like it to be down like this, I can flip the arrow so that it puts Z up. That's entirely up to you. That's maybe more convenient. So that's the first marker that I did for this base, and I say okay. All right. Now let's do one for this fellow. Okay. So I'm going to do another marker. I select this piece by geometry, and it's convenient for me to actually select this circle, that circle. Notice that the Z is also up. This one was also up, so that's good enough for me. And I say OK. Notice that these markers are created. For example, when I did one for the let's see now, when I did one for Uh, the base, this is the manual one that I made. Link one is the manual one that I made. And now I'm in a position to create that Revolut join. You can do all the markers for the other ones too and do it at the end, but I'd rather do it right now. So we go to join, Revolut, and I will select the two markers. Now, what are the two markers? The order of it doesn't matter. I select this marker and that marker, and it better end up in the position that we want, right there. See that? Now I repeat this thing. I want to put this pin inside of that hole. So let's go and create our markers. Let's do this one first. By geometry, and I select that circle. Again, Z is up. Good, I like that. And let's do a marker for this fellow. It's this green one, which is link 2. And I select this circle. Over here, by geometry, I select this circle. Now, both of them Z up, which is fine. That's good. And now that I have them, I can create the joint. So we go joint, Revolut, this marker, and that marker. And I say OK. Very good. Now I need that fellow, this hole, and this link 3. So I need markers. So marker, let's do it for that guy by geometry. And I will select that circle. OK. Very good. And I do the same thing here. Okay, so this one, I can create a marker, but the marker for this fellow was over there, okay? But I want it somewhere in the middle of this. So let's see if we can actually arrange that. So let's check that. Let's see. We go to marker. There's my part. By geometry, the only thing is that I don't know if I selected this, where it's going to put the marker. We'll find out. So right now it's over there. See that? This is the marker at the origin. I don't want it there. Let me see if I can put it somewhere right there. You see that? I selected the point and put it right there. But the direction of the Z, again, I want them to be the same. So I flip this. Oh, I took the axis. Okay, took the axis. Okay, fine. I'm flipping, oh yeah, Z up, it really doesn't matter. You say okay. And now we're going to create a prismatic between that marker and this marker. So a joint, prismatic between this marker and that marker. You say okay. Now I'm going to bring this point and put it on that curve. So let's create our markers. I need a marker at the very bottom here. Let's do the marker here. This is the body. I select this point. I have a point here by geometry. I do have a point here. See this? Say okay. Now, let me go ahead. I had a point here in the tutorial 13, which I ended up deleting in this problem. Let's see if I can make a marker with that path. And by geometry, and I select a point. Actually, geometry does not work. Cancel that. Let me see for a second. Marker. There's my body. Where does it put it? It just put it right there because that was actually the origin of the part. Now, by geometry, I don't have a feature to do this. See that? I don't have a feature to do that. The other option is the following. Let me cancel that. We may not actually need a marker there. Let's find out. Let's do a joint. It is possible to create a point here and then put the marker at that location, but let's see if you actually need this. So point curve joint. Okay. The curve is this. Yeah, it looks like we don't even need this marker here. And the point is that point. Yeah, and then it's okay. So this last marker that I did here probably is not even needed. Yeah, it's not even needed. Yep. Okay, good. So let's check something. Let's go to Kinematic Player and let's see if things work. Let's check. Yeah. Is this the one? Yeah. Okay, so it is working. Let's go ahead. Let's go ahead and put some physics into this. So we're gonna first of all, this is double click on that. I want a kinematic step, although it really doesn't matter. It could have dynamic 5 second. That's fine. And I'm going to select the driver. And for the driver, I select the point curve joint. Right here, click on that box, which allows you to specify the value. This is the speed that I want to specify, or the velocity of that point curve joint. And let me, for now, put it, I don't know, maybe 0.5 meter per second and see how it looks like. So, okay. And we can visually try and see if we can preview it first for running it. Just give it time. Yeah, that's good. That's good. Very good. And oops, yeah. So let me go and simulate, run, finish. Select this last result, last line of the result branch, and then result, play animation. And yeah, let's do it continuously. We can slow it down probably. Yeah. Okay, good, good. There's physics here. This is not a cartoon. There is physics because I specified the velocity of that point curve joint. And if I wanted to, I can go and plot the acceleration of a point and stuff like that. And if I'm doing dynamic analysis, once you have the acceleration, automatically calculates forces and things like that. But this is, that's physics in it. Now, notice that what I did, contrary to tutorial 13, I created all the joints manually inside of the motion design. And that requires some additional, fooling around with markers and things like that. I also created a marker that was not needed, and that's fine. So it happens. Anyway, that's it. I will try to create another a video for markers specifically, these directions, basically basically how you can systematically, where is this? You can systematically talk about things like this, okay? My problem was simple enough that that was not necessary. All right, folks, good luck.